Hi everyone. Today's lesson is on dilations. Now, the notes here, if you have your notes at home, these follow them almost to a T. I did make some changes to make it a little bit easier for us to learn this way. So if you have your note packet at home, you can just use those notes and then just take a little bit of a side note when we come to something that's a little different. If you are unable to print these, it still is a good idea to maybe write down some of this information on loose leaf. Okay, so let's start off here. First, we have what a dilation is. A dilation is a transformation that produces an image that is the same shape as the original, but a different size. So we say that a dilation is similar to the original figure. The dilations that we are going to look at are going to be centered around the origin. So in the future, you'll see other dilations centered around other points, but not for us, for our 8th grade dilations unit here. All right, so we reviewed simplifying fractions for a reason. We're going to see a little bit of that with dilations here. So we have something called a scale factor. So when we dilate an image, it is going to change size depending on that scale factor. And if you think of the word factor, we should hopefully think of multiplication. So that's essentially what we're going to end up doing here is a little bit of multiplying or dividing using that scale factor. So our scale factor is going to be the fraction or a ratio here that comes from the length of the image, okay, over the original or the pre-image length. So if our scale factor is greater than 1, then the figure is going to be enlarged. Well, think about that. You take a number and you multiply it by a number greater than 1, it gets bigger. If the scale factor is between 0 and 1, so in other words, a fraction or a decimal, the figure is going to be reduced. So if we say something's half the size and we multiply by a half, right, it's getting smaller by half. Okay, so not really hard fraction stuff. All right, so our rule is just simply multiplication here. So we have our original coordinate at x, y. After we take that scale factor and we multiply it by the x and y coordinates, we get our image, our new figure. Okay. So, for example, if the scale factor is 3, our rule would look like this. We have the original x, y. Okay, and then we're going to do 3 times x. I'm writing this in the wrong spot, aren't I? Bring that down here. X, y, 3 times x, and 3 times y. So that's it, just multiplication. Okay. Now, however, we're not graphing them. We're going to look at the dilations and come up with that scale factor. So we're kind of going to look at this in a little bit of a different way as well. All right. So we've got triangle ABC with the vertices here. What are the vertices of the image with a scale factor of 4? So all we have to do is multiply. So for A, or A prime, we are going to have scale factor of 4. So 4 times 0 and 4 times 2. So that is going to be 0, 8. So it's just multiplication. B prime, you're going to have that same scale factor, 4 times, well, here we've got a 4, a lot of 4's in this one, and then 4 times 4 again. So our new coordinate is 16, 16. And then we have C prime, -1, 4. So we have 4 times -1 and 4 times 4. Okay. So that is -4 and 16. Okay, so this is just going to make that triangle enlarge. It's going to look like the same shape though. And we're going to talk about what makes it look that way coming up here in just a minute. All right, so here's another example. So if you are following along in your notes, this is where it's a little different. I already drew down these images. If we were in class, we would have drawn these together. So we have the quadrilateral, PQRS, given the vertices there. I already put them on the graph, and I dilated it by a scale factor of 1/2. Okay, and it's shown in the graph. So that is dilated around the origin at a scale factor of 1/2. So this image down here is smaller than the original, right? Smaller by 1/2. So let's look at the coordinates and compare and see kind of how that half comes into play. So we were given the coordinates of the original. I could rewrite them here too so that you guys can compare them. So if I'm looking at just P, I've got -2, 4. Now P prime, if I take a look at P prime, that is -1, 2. -1, 2. So comparing those two coordinates, -1 is 1/2 of 2, and 2 is 1/2 of 4. So essentially we took this original, we multiplied those by 1/2 to get our answer here. So the original Q they gave us was 4, 4. So Q prime, so if you're looking at the graph, if you have this in front of you, Q prime, we take a look at that, this is now at 2, 2. So 1/2 of 4 is 2, and that's both for x and y. So this is 2, 2. Okay. Our original r is 4, -2. Now we don't even need the graph to do this because we know that the scale factor is by 1/2, so we're just taking 1/2 of each of these. So 1/2 of 4 is 2, and 1/2 of -2 is -1. And if I did this correctly, we go over and take a look and make sure that's where r prime is. So we're over at 2 and down at 1/2. And our last one here, S, the original is -4, -4, and S prime, then 1/2 of this, 1/2 of -4 is -2, and 1/2 of -4 is -2 again, and we take a peek over here at S prime, and it's at -2, -2. Okay. If you need a second to pause your video and think about everything we just wrote down, go ahead and do so. Okay, but each of these are halves. Okay. So now we're going to look at part B. It says demonstrate these quadrilaterals are similar by comparing the ratios of the lengths. So when we have similar figures, we say they're proportional, and when they're proportional, we pretty much have equivalent fractions. Okay, so going back to what we saw in the previous lesson. So the comparing the ratios of their lengths. So some of these lengths we can't quite determine on the graph here, these slanted ones. We can't see those lengths. We don't have the knowledge to find that length yet, but we can determine our lengths that are vertical and horizontal. So from P to Q, we have 1, 2, 3, 4, 5, 6. So now the length is 6. P prime to Q prime, our length is 1, 2, 3. Well, compare 6 with 3. So P to Q is equal to 6. And the length of P prime to Q prime is 3. Well, let's think about, and I could come back here for a second, what we said about scale factor. Scale factor is the image over the pre-image, so the image over its original. So the image is 3. So let me even write this down. Image over pre-image or original. So that's 3 over 6, which simplifies to 1/2. So the other one was our vertical lines here, 1, 2, 3, 4, 5, 6. Well, this happened to be 6 again, and 1, 2, 3. So same thing. Those come down to the same ratio, 3 to 6, or 3 over 6 simplifies to 1/2, 1 to 2. Okay. So again, we don't have the knowledge to find the distance of this slanted line. Okay, but those are also in that same ratio. This length here is 1/2 of this length. All right. Part C, what do you notice about the angle measures of the two figures? Now, if we were in school and we were on the smartboard, I would draw over these angles and show you, prove to you exactly what these are. But right here, we're going to have to just use some of our knowledge we have of perpendicular lines. So P to Q here, or I'm sorry, angle PQ to R makes a 90-degree angle. If we look at P prime to Q prime to R prime, that's still a 90-degree angle. So that angle measure stayed the same. Okay, with the rest of these, a little bit harder to tell, and I don't have a protractor with me, or we could also measure them. If you have one at home, you can go ahead and measure these at home and try it out. But these angles right here stayed exactly the same. So if I could slide this over to here, it would fit in there perfectly. So P and P prime are congruent. Those angles are equal. Same down here. If I could take this S and S prime and slide them together, you'll find that these are the same angle measure. So if you want to take a protractor out at home and measure those, they're exactly the same, and so is R and R prime. So down here, our angle measures are all the same. So we'll say the angle, the angle of, or angles of the image are congruent to the angles of the pre-image. Okay, so for a figure, shape, to be similar, those two things need to happen. The side lengths need to be proportional, okay, meaning we have these equivalent fractions, they're proportional, and our angle measures are exactly the same, or they're congruent. So the angles have to stay the same in order for our figures to look similar. If we started to change the angles, well, now we're changing the look of the shape. Okay. All right. A couple more examples here. I know this video is a bit longer than a few of the others. All right, but we're now in the home stretch here. So you may want to try to pause the video and read some of these examples. Try them on your own before you see these answers. So example 4. If the scale factor 5/2 is 5/2, I'm sorry, if the scale factor is 5/2, how would you write the general rule? And then, is this going to enlarge the figure or reduce it? Is it going to be an enlargement or a reduction? All right, so again, pause the video if you wish. So the rule, we've got our xy, and that's going to change using multiplication. So no need to change this into a mixed number. So 5/2 x and 5/2 y. So now we think of fractions, sometimes we think of reduction, but this fraction is a mixed number, or could be written as a mixed number. This is a number greater than 1. So this is going to be an enlargement. Okay, so careful with fractions at times. That's why we're looking at this example. Fractions can trick you at times if you're not paying close attention. All right, here we have these two almost looking like diamonds on our graph. All right, quadrilateral A prime, B prime, C prime, D prime is a dilation of the quadrilateral A, B, C, D. Find the scale factor. Classify the dilation as an enlargement or a reduction. So we need to pay close attention to what the original was and what the image is. And maybe you should decide if it's an enlargement or a reduction first, so then you know if you're looking for a whole number or a number, maybe not necessarily a whole number, but a number greater than 1, or if you're looking for a number between 1 and 0. Between 0 and 1, said that backwards. So original's out here. This is our image, so it got smaller. So this is a reduction. Move this over a little bit. So I know that my scale factor, I'm going to shorten it up, has to be a number between 0 and 1. All right. So you could do this by looking at sides or by looking at coordinates. And now if we tried to look at the sides, just like earlier, we can't tell here. We don't have the knowledge to find the length of that just yet. So we can compare coordinates. Now every single one should work the same way. So we could do them all to check it, but you really only need to compare one of them. So let's take a look at A. So I've got A over here at 6, 0, and A prime is at 2, 0. So remember, the image, I'll write it in here again, image over pre-image so the image goes on top, so that's 2 over 6, which simplifies to 1/3. Okay, so our scale factor is 1/3. Okay, so that small diamond in the inside is 1/3 the size of the outer diamond. 2 more examples. Again, pause your video. We are going to do the same thing. Is it a reduction or an enlargement? And what is that scale factor? So here, looking at this one here is our original on the outside. On the inside, it's the image, so it's a reduction. All right, so they even list our coordinates for us, make it a little bit easier to see. So if I'm comparing A prime and A, and again, I'm going to put my A prime on top. So if I'm comparing the X part of this, I got -1 and -2. Oh, probably should move it over so you guys can see it if you don't have the sheet in front of you. -1 with -2. That's the X of my A and A prime. And if I look also at the Y, so prime on top, 2, compare it to 4, well, negative over a negative becomes a positive, and 2 over 4, that also simplifies to 1/2. And if we check every other coordinate, 2 here, right, 2 over 2, both of those simplify to 1/2, and the same with C, right, that's an easy one. 1 over 2 is 1/2. These all are going to simplify to 1/2. So our scale factor here is 1/2. And the last one. All right, so here we're looking at the original. Now, this one looks a little different. It's not going around the origin, so it doesn't always have to be around the origin. Depending on where our original is drawn, that's going to make where our scale factor goes. So if you kind of look at this, though, it comes out here. I don't know, the word would be like, almost like straight lines, like evenly. So that is a dilation about the center. It's just not around the center. Okay, so they don't have to necessarily fall inside of one another. So this one, original's here. Our image now got bigger. So this is an enlargement. And if we compare, we can compare these lengths because we've got some sides here that are straight. We could do both, look at the coordinates and look at the lengths. They're going to be the same thing. So let's see, our original is at 2, and this is 1, 2, 3, 4, 5, 6. So again, image on top, so 6 over 2. We know this is an enlargement, so we don't want a number less than 1. 6 divided by 2 is 3. So this green triangle is 3 times the size as the blue triangle. So the scale factor here, scale factor is 3. Okay, and if you compared your coordinates, you guys can try that out on your own, you'll see that they all should equal out to 3. Okay. All right, guys, I know this was a bit longer. Thanks for hanging in there with me. Go ahead and try the worksheet and the Khan Academy problems throughout today and tomorrow. All right, have a good one.